Okay, so 17. A display box needs to be 12 centimeters high and have a base area of 800 centimeters squared. It will be cut from a rectangular piece of cardboard as shown. The width of the box is X and the depth from the box from front to back is D. Express D in terms of X. Okay, so the base area is 800 centimeters. Okay, so this here is X. This has to fold up to become, so this here is D. So if we take it that this is 800 and this is X multiplied by D is the area, so XD equals 800 because length by width equals the area. So D therefore is 800 divided by X. Okay, so that would be 800 divided by X. Now, show that the total area of the cardboard piece is given by A equals 1088 plus 12X plus 19,200 all over X. Okay, so what we're looking at here is a 12 by 12 cutoff. Okay, so what we seem to have here is this is 12 and this here is 12, and this makes this distance D minus 12. So if we take areas, we'll call them area 1 and area 2, which represents a trapezium. Now please remember the formula for trapeziums. Okay, so trapezium is the bottom height plus the top height, so B plus A divided by 2 multiplied by H. So what we're going to have is we're going to have D plus D minus 12 all over 2 multiplied by the height, and the height is going to be 12 across the height. Okay, because the area of a trapezium is A plus B over 2 multiplied by H. So once we've settled on that, what we're going to get is 2D minus 12. Sorry, 2D minus 12 all over 2, which is going to get me D minus 6. This D minus 6 has to be multiplied by 12. That's going to get me 72D, oh sorry, 12D minus 72. So 12D minus 72. Now once we have this 12D minus 72, what we're now going to do is find this total area. Okay, so let's see what we have. So we got 12D minus 72 for area 1 and area 2. So that's another 12D minus 72. And then we're going to look at area 3 here. Area 3 is going to be D by X or XD, but we know it's 800. So area 3 is going to be 800. And then finally we're going to have area 4. Area 4 is the base one here, which is going to be X by 12, which is 12X. And this is what the surface area is. Now what we're going to have here is going to have 24D. We're going to have 12X, and then we're going to have 800 minus 144. So 800 minus 72 twice, or minus 144. We're going to get 656, so plus 656. Okay, now, so we next know is that 20D is 800 over X, so we're going to get 24 times 800 over X. So what's 24 times 800? Is 19,200. Okay, so it's going to be 19,200 all over X plus 12X plus 656. Now 656 comes from the base of 800 minus the 144. I think we have accounted for everything. We've counted for the bottom one, the sides and the back. So I'm actually just going to disagree with this answer of 1088, and I'm going to say that it's 656 instead. Now this shouldn't affect the next answer anyway. Find the minimum value of A and hence find the dimensions of the cardboard piece which yields its minimum. So yields its minimum would be dA dx, and remember we're going to change that to 19,000 x to the minus 1. So we're going to multiply it and get minus 19,200 x to the minus 2 plus 12, and then we're going to get minus 19,200 all over x squared plus 12 equal to 0, because the first derivative equals 0 for a minimum or a turning point. Bring it over to the other side, we get 12 equals 19,200 all over x squared. 12x squared equals 19,200. Divide 19,200 by 12. We get 16,000, so x squared equals 16,000. Square root that, and we get x equals 40. Okay, so we're going to get x equals 40. Now, x equals 40, it says what is the minimum value of A, and hence find the dimensions of the cardboard piece that yields this minimum. So that we know that x equals 40, and then we're going to have to find out what d is. D is going to be 800 divided by 40, and d is going to be 20. D is going to be 20. Okay, so that is it.